Right, so I know this is Australian cobotics, but I thought what would be interesting would be to talk about the human element behind human-robot collaboration. And I think why this is important for creating successful robotic technology. And I'll base it on my experiences abroad mostly. So Sheila kind of already touched on my background, but as she said, I did my bachelor's degree and my PhD with the University of Technology, Sydney. When I was doing my PhD, I worked on the submersible pile inspection robot. So what happens at the moment is divers have to go down underwater and use high pressure water to clean marine growth off bridge columns. And this is obviously very dangerous. The high pressure water can actually be lethal. And this project was partnered with the Roads and Maritime Services from memory. I can't remember if it's changed names since then, but the idea was the robot could go down and do a lot of the hard work and therefore prevent human exposure to hazards. And then my PhD topic was around controlling floating mobile manipulators. So I did a whole bunch of research on motion prediction and predictive control. And then I did my first postdoc at the Italian Institute of Technology in Genoa, Italy. And I worked on an actual collaborative robot. This was called the ergoCub. And the idea was that this robot would be obviously a collaborative robot to assist people in the workplace. So I think the number one cause of injuries were musculoskeletal from repetitive strain and heavy lifting. And the idea was this robot wouldn't really take away people's jobs, but be able to help them with repetitive tasks, lift heavy objects together. And so my focus on this research was doing the bimanual manipulation. So doing the upper body control, the two-handed grasping. You can see it manipulating my lunchbox here. And then I did another 2-year stint at the University of Leeds in a lab that focused on surgical robotics. And what drew me to this lab was they mounted gigantic magnets to these robot arms. And then by wiggling these magnets around, you can change the magnetic field. And they can actually make these soft magnetized tentacle robots crawl through your body. And the idea was you could put sensors or surgical instruments and perform minimally invasive surgery. And this was basically to improve patient outcomes, right? Instead of cutting people open, you can send in these tiny soft robots and use magnets to make it crawl. So, yeah, that was really cool. Um, so this seems a bit of left field, but there's this really interesting book that Henry Ford wrote, Today and Tomorrow, and he's the father of mass production, mass manufacturing. He basically invented the world we're created today. And what stood out to me when I read this book is he said that the reason he wanted to mass produce cars is to make them cheap and affordable to everyone. At the time, people were living and working on the job site and would only go home to see their family on the weekends. And his motivation was that by making cars cheap and affordable for his workers, they could travel home at night and spend evenings with their families, right? So you didn't have to, you could live at home during the week and just travel to work during the day. And this is something we take for granted. But what he really said was, people think of business as something of dollars instead of something as a service. And this kind of resonated with me because I think of robots as something that should serve humanity. There's a lot of anxiety over robots and AI taking people's jobs away, but a theme that's been playing out from my research is all these robots are supposed to help people in some way. They're not replacing them, they're making them more productive or more safe. So I think, yeah, this is something I'm passionate about in my philosophy and approach to robotics research. But I wanted to actually talk more about human collaboration that I've dealt with when working on a collaborative robot. Um, so I'll show you a video in a minute. This was a demo we put together very quickly for the ergoCub robot. And there's actually lots of things happening simultaneously to get this very simple demo up and running, right? We have a vision system and visual servoing, and we have to control all the arms and the motors on the robot, and there's a real-time decision tree happening. So there's actually an action recognition module. So there was a PhD student working on detecting and recognizing actions through reinforcement learning, object detection as well, and this feeds through a vision system. This goes to a behavior tree. So this is like the brains. So based on what the robot is seeing in the environment, makes an intelligent decision about how to respond. And then this gets sent to my robot control module. And so I have modular motion primitives that can be coordinated to perform a more complicated task. So hopefully this will run. So immediately you can see the robot catches a glimpse of my colleague. And if you look carefully in the background, it's actually doing face detection and following his gaze. And immediately it will switch to detecting the object. So there's object segmentation happening here in the image. And then the decision tree sees that the object is close enough and it calls the behavior to grasp the box. And then my colleague programmed in some cute reactions on the face module there. And then again, action recognition. So once you're close enough and you go to shake its hand, we can make it autonomously respond. So this very simple demo took a hell of a lot of expertise to get up and running in terms of, like I said, both the AI and vision systems, also the control and the logic, and we had multiple software modules running together that had to coordinate seamlessly. Oh, can't advance. So the story I want to tell is about what happened in 2023. And at the beginning of 2023, we had to put on a big demo for our project's industry stakeholders who were funding it. And that's a big photo of about half the team because I cropped it. But at the beginning of 2023, our team leader left. And he didn't write a single line of code for the robot. So his responsibility was the behavior tree, and he produced nothing and left for another job. And two of our PhD students had to write this in about a week, and they did an incredible job with it. So that was very stressful. We had about 3 weeks to prepare for this huge demo because we had all just come back from Christmas, New Year break. We had limited access to hardware, so we'd been working on the project for about a year, but this robot here had only just been delivered to us, I can't remember exactly, but maybe a month before Christmas. So we didn't even have actually time to work on the robot. Everyone you can see in that photo, plus more, were trying to get access to this robot to implement their research for the demonstration. So very limited testing and development. I was made the new team leader, and my boss told me I had to do two 30-minute presentations. So an hour-long presentation to stakeholders who spoke English as a second language and knew nothing about actual robotics. So not only could I not talk about quadratic programming or convolution neural networks, I also had to be careful about my choice of English vocabulary. I think I remember finishing at 9 p.m. on a Friday. We stayed up all night working on this. I had to work all day Sunday on my presentations. And then, of course, I had to present on the Monday. And then that was about a 12-hour day because at the night time, I was invited to dinner with all the stakeholders who all spoke Italian. So I was exhausted. And you can imagine this is how we were feeling leading up to the actual deadline for this demonstration. And then to top it all off, my boss then says, actually, you're going to ICRA in London in 2023 to demonstrate this system that we have. So we had about 3 months to do this, and 3 months is much better than 3 weeks, but still a very, very tight deadline. So there's a really good quote, which is falsely attributed to Abraham Lincoln, but I did find a reference for it. And there's kind of a story in there. It says a woodsman was once asked, what would you do if you had 5 minutes to chop down a tree? And he answered, I would spend the first 2.5 minutes sharpening my axe. And to really make this project succeed, we really needed a lot of collaboration and planning, right? So being excellently prepared. So one of the first things we did was a collaborative brainstorming workshop. And we looked at what we did well with that previous demonstration, what we could improve, and how we could impress people. And as you can see, the team collectively had many, many, many ideas about how we could improve what we did with that demonstration. We did this other thing called an affinity diagram. So we took all ideas and we grouped them based on common themes. And the idea behind this was that it just makes it easier to manage, right? So coming from this to this, now we have manageable groups of tasks that we have to work on. And then next we did a prioritization matrix. So we have to work on all these different things to fix up the robot and the demonstration. And we use this project management tool. And basically we compared every task pairwise to every other task. So basically we look at task A and we basically agree task A is about 5 times more important than task D. And conversely, that means task D is 1/5 as important as task A. And then we add up all the rows, right? So we sum up all the rows, and then we can implicitly find what the team as a whole thought we should be focusing our attention on in the 3 months. So the number one thing we concluded was that our code has to work cross-platform. Like I said, we only had access to that newest prototype a limited time. We had to share amongst maybe 20 other people. So we needed code that worked on the 2 older robots that we had access to and also with simulation. So this allowed us to do parallel development and bench testing before we even moved to the real thing. And then if something broke, then we had backup systems in place. Another important one is the robot gaze follows the objects. We were the humanoid sensing and perception group. So that's our bread and butter. If we can't do this, we're basically a failure. And the other thing was the thrift communication protocols. So if you're not familiar with software, I certainly wasn't familiar with this concept, but this is like the ROS client server. So basically, standardized communication packages that exchange information between all the different modules on our robot, from the vision system to the decision tree to the motor controls, right? So we have to have these standardized in place because they're modular and we can swap them in and out. And I don't need to know anything about decision trees, and my colleagues don't need to know anything about robot control. As long as we have an agreed handshake on what information is exchanged, we can work independently almost. We also did our task breakdown. So, all the things we had to do, we brainstormed all the things that could possibly go wrong. We looked at all our countermeasures, like how we might preempt all these problems. And another really powerful tool we used was this thing called a Carnot model. And I think this is relevant for human cobotics, service product design in general. But the idea is this conceptual model splits products and services into 3 categories. So the first category are these minimum requirements, and these are things you have to do as a bare minimum to be successful, right? So if you don't implement them, your customer will be very dissatisfied. But no matter how well you do it, they're not going to be impressed, right? It's just, it has to work. So like as a bare minimum, we have to get the vision up and running on this robot because we do perception. The next are the performance drivers, right? So the better you do, the more happy your customer will be, right? So spend time working on these. And the last thing we thought about were these things called wow factors, right? If you don't implement them, no one's going to notice. But if you do implement them, you can really surprise and impress people. So for our projects, as an example, this is just a small sample of the things, but obviously the robot has to move. We have to have the correct action recognition happening as a bare minimum. And it seems kind of trivial, but one of the things we brought up is like, we got to make sure we book our trip to London, because if the robot gets sent over and we've failed to organize in all the chaos that's happening, we can't put on our demo. Another one was like, in terms of performance requirements, we need smooth natural motion, right? We don't want these really old 80s style robots that are very rigid and creepy. We want something that's very fluid, human-like. And another thing is we can grab different objects, obviously, because objects come in all different shapes and sizes. In terms of the wow factor, one thing we thought about was putting idle actions in. So making the robot, instead of just standing still, kind of, I don't know, looking at stuff, moving around, making it more lifelike and human. also programming in multiple reactions to different things that people might do. And then a colleague suggested also jumping over obstacles, which was way beyond our skill set, but it was a kind of a funny thing to bring up. So based on that, then we did our task sequencing. Basically, all the tasks in order based on dependencies. And what really became important after this workshop was that there's a few nodes where all these tasks are coming into place. So these are the project milestones. And based on this, we can tell if we're on track or not, right? If we fall behind on any of these milestones, then we're going to miss the deadline for the 3 months to get to London. And after all this, so I think we spent a number of weeks working on these. But in the end, we put this all into GitHub. I know people use GitHub a lot for uploading code, right? Version control, etc. But GitHub is actually a really excellent collaboration platform that I still use now with collaborations both here and overseas. So you can see we had all the tasks done as issues. They can be put in the Gantt chart. You know, we got our milestones from our task planning put in. So I really can't stress enough how useful these kind of collaborative tools are for project management. And then, of course, this isn't our project, but everyone knows there's the Kanban boards. We were using these for our agile sprints of the week leading up to leaving for London. And in the end, it was a huge success. So all this collaborative work, teamwork, planning after our not quite failed first demonstration. We were in London. I saw some of the colleagues from Australia there. We were on television as well. That's at our booth at ICRA. So yeah, this teamwork and collaborative effort behind this robot technology is really what made this a huge success. I want to circle back that, you know, I brought up this like trivial idea of booking the trip to London as a task that we have to keep track of. And it seemed kind of silly at the time, but actually using the GitHub issues, we were able to have this as a discussion board because we had issues with bureaucracy and booking policy. But these little things that you keep track of can be really important. So I thought it was nice that we had a dedicated communication channel for keeping track of booking our actual flights and accommodation. So I think what makes a good project and, you know, a robotics project in general is having very clear objectives about what we have to do and a complementary skill set. So everyone on the team had a unique skill that contributed, and none of us could have succeeded without someone else's work. It just wouldn't have happened. And then, of course, as you can see, extremely thorough planning. And, of course, really strong collaboration. So really what I put this down to is my team. So this is my team that I worked with in Italy, and I would go back every 6 months to visit them, but these were really fantastic people. And so based on my experience, it's really the people behind the robots that really make the technology shine and make it a tough but fun challenge to work on. I want to pivot a little bit. I used to do this type of project management called Lean Six Sigma. So Six Sigma is statistical process control, and the lean part comes from lean production or the Toyota production system. And one of the things they talk about in the Toyota management philosophy is the idea of Genchi Genbutsu, and it translates to actual place, actual thing. So the managers stress to their junior engineers that you can't solve a problem sitting behind a desk. They actually make them go stand out on the factory floor and observe work as it's happening and observe problems for themselves. And I think this is a temptation, certainly that I've had, is you sit in a lab behind a screen working on code and writing up research papers. But I think this idea of going and experiencing real problems firsthand can be very valuable for robotic technology. This is a photo of me when I was about, I think, 25. So when I was doing my bachelor's degree, I did a scholarship with Sydney Trains, and I was meant to be working in corporate, but I I actually have a trade as a mechanic, and I put this idea of Genji Genbutsu into practice. So over the summer holidays, I actually did a 3-month sabbatical as a train technician. Normally I was meant to be running projects to fix business and engineering systems, right? Big corporate level projects to try and improve how Sydney Trains functions. But, I thought to myself, how can I be fixing trains if I've never actually fixed a train with my bare hands? So I took that photo after a particularly hot day in the middle of the summer, covered in filth and grease and sweat. Um, and just this little detour in my career led to me starting up two big projects that I proposed that are worth about $2 million. I got project management qualifications out of it. And when I left at the end of the 3 months, the technicians actually came up to me and shook my hand and said, John, you're the first engineer that's ever come down to work with us one-on-one, right? So all these engineers are sitting up in their air-conditioned office, dictating how work should be done. I was the first one who put on the blue collar overalls and got my hands dirty with them. So this is something I still like to take into practice with robotics research. So when I was in Leeds, I got some funding to do a collaborative project between Sydney and Hong Kong on using these soft tentacle robots for heart surgery. And the professor from Hong Kong came over to Leeds to visit. And so one of the things we did, as you can see on the background, I love my collaborative workshops. We did a collaborative workshop looking at the process of what actually goes into performing heart surgery. Because as an engineer, I got no idea. I've never cut open someone's heart. And this is really valuable exercise, right? So we mapped the process and looked at all the touch points about what happens to the patient and what doctor is doing what, and then identifying the critical points. What are the challenges? What are the research questions? And what I found really fascinating was my lab had been working on these surgical robots for several years now, and none of them had actually asked a radiologist or a cardiologist, what's most important for this kind of technology? What's most important to you? And what really surprised me that I never thought about is that force feedback actually is the most critical skill for a radiologist or a cardiologist. I spoke to a radiologist in the UK, and she said she was one of less than 5 in the whole country who could actually perform certain surgery because she could manipulate the catheters with such fine precision. And then I actually went to Hong Kong as part of the collaboration to see what cardiology is like at the hospital there. And one thing that really stood out to me is Hong Kong is a very crowded place, right? There's massive skyscrapers everywhere. All the shops and apartments and houses are super tiny, and even the surgical theater is really cramped. So it kind of became an interesting question. If we're developing all these robots and putting giant magnets on them, how are we going to fit them inside this crowded operating theater? So by actually stepping outside my lab and talking to surgeons and seeing this for myself, I actually learned quite a lot that I had taken for granted about how we do things over, say, in Australia or in the UK versus what things actually look like for people in another country like Hong Kong. So I just want to finish up with this really interesting book that I read years ago that resonated with me being a mechanic, but someone who's done academia as well. It's called The Case for Working with Your Hands. So the author did a PhD, I think, in political philosophy from memory, but he runs a motorbike repair business. So he can talk really deeply about what it means to fix things. It's really fascinating. But he has this chapter in there called Seeing Clearly or Unselfishly. And he talked about this other book, which I'll get back to. I'll get back to the original book. But he talked about this other book, The Art of Motorcycle Maintenance. And so I went and read this book. And the author of this book talked about a story where he took his motorbike to a repair shop. And the guys in the repair shop were kind of laughing and having fun and listening to the radio and weren't really paying attention. And it took a while to get them to come over and talk to him. And the line in the book is this young mechanic, he barely listened to the piston slap before saying, "Oh yeah, tappets. Tappets. I should have known then what was coming." And then afterwards, he talks about how he took this motorbike back to the repair shop 3 times. And the mechanics stuffed it up every time. They never really identified what the problem was. So they assumed it was tappets without even investigating. Just took a look. Oh, it's tappets. It was really piston slap, whatever that is. So 3 repairs later, lots of money. They damaged his motorbike. They returned it to him in pieces. Well, not in pieces, but it was so poorly put together, he could have died driving it out of that workshop. So really interesting story. But then, as I said, that original book I referred to, he writes about this from a philosophical perspective. And he says, Pirsig's mechanic is idiotic because he fails to grasp his role, which entails, or should, a relation of active concern to others and to the machine. And in this context, Matthew Crawford is using idiotic in the original sense from the Greek, I think, idiota, which means private. And he's basically saying these mechanics who failed to fix this motorbike were privately concerned, and they weren't taking on a public responsibility in service to a customer. And to me, this is a very important part of robotic technology because, again, like I said in the beginning of the presentation, a lot of fear and anxiety about robots taking away jobs, replacing people. And I think we should have active concern for people, not just that we make robots for, but the people we work with, as well as the technology we're developing. So anyway, I highly recommend this book. It's really fascinating. But that kind of concludes my presentation. So if you want to know more about the books I talked about, I have a reading list on my GitHub page. And a shameless plug here, I'm also looking for work. So if you're doing robotic stuff or need help solving problems, get in touch. I'm keen. So thank you, everyone. Any questions?
I had a bunch of questions if I can
Yep.
jump in.
Mm-hmm.
Um, Firstly, thank you so much. The presentation was really great. So I'm James. I'm doing my PhD at the moment with the Australian
Mm-hmm.
Cobotic
Mm-hmm.
Centre, and so my background, I've come from design and psychology, and but then I'm
Yep.
obviously dealing with robotics. It starts to merge into sort of engineering in these other territories, and then the
Mm-hmm.
work I've been doing is in robotic assisted surgery and then medical
Nice.
manufacturing,
Yeah, yeah,
where
yeah.
they're not using robots at the moment. So kind of how do you do that? And part of what I'd come to, well, the understanding I've come to is this importance of familiarization and embedding yourself in those environments to understand how they actually work and
Yes.
to
Yep.
design robots effectively. So everything you're saying is has been really it's great to hear that this is sort of
Yeah,
the
yeah.
and I really liked you'd use this term Genji Genbutsu. Is that
Yep.
correct?
Yep. Yep.
Um, that term to me is really interesting. So thank you so much just for introducing that. It's I'm writing my discussion at the moment, so I'm definitely going to pull
Mm,
that and pretend it was part of it or the whole time.
sure.
Um,
Yep.
but I was wondering, I mean, obviously it's about this sort of embedded in the space. I was wondering if there's any papers or authors that write about this that I could pull in for that, or if you know of
In terms
any
of
books.
in terms of actual robotics or tangential stuff.
Tangential's fine. I love tangential, so tangential's fine.
Well, I mean the 3 books I talked about, there was Today and Tomorrow by Henry Ford,
Yeah.
talking about business as a service, right? It's not about making money, it's about something that serves humanity in a broader sense.
Mm,
The Toyota management, the Toyota way, the management philosophy, again, that idea of Genshi Gebutsu, like seeing problems with your own eyes. Um, Definitely that one by Matthew Crawford,
yeah.
really fascinating, the philosophy behind what it means to really solve a problem and fix machines. But that translate he being an academic, he also talks about the implications for white collar work, right? What's the difference between
Mm,
blue collar, white collar? What does it mean to actually work on a problem with your own hands versus work on a computer where everything's ephemeral? Um,
yes.
yeah, and then also Zen and the Art of Motorcycle Maintenance.
Yeah, familiar.
Yeah. But I mean, like, look at my reading list. There's a whole lot. There's lots of stuff on
Yeah,
design,
that'd be great.
science. I read a lot of different things. And there's really fascinating ways that these can connect to research.
Yeah, awesome. Thank you. I'll take all those down. I guess there was another less pragmatic question as well. Or
Mm.
maybe it is equally pragmatic around. I guess to me, and coming from like I guess a human-centered design perspective, and something
Yep.
where the idea of engaging end users and bringing them into a design process, obviously it's messy and it has issues, and there's
Mhm,
questions
mhm.
around bias and all these sorts of things as well. But I'm also interested in your thoughts around why that kind of approach is so novel. When to me, coming from these spaces, it's sort of this seems a lot more obvious, but I found I almost have to defend it as a concept in entering
Mhm.
these very sort of validation and metric driven spaces.
Yeah.
How you do these processes and how you validate engaging an end user in something that looks a little bit interpretive, I guess. Um,
Uh, Yeah, I can understand the perspective because obviously my background is engineering, but I also really like
mm,
design and I studied art for a bit. So I've
mm,
spanned all of this, and I know the temptation as an engineer is just to sit behind a computer and work on math problems, right? You don't want to deal with
mm,
people. That's kind of partly what draws me to engineering, but at the same time, you have to get involved with people. Yeah, I think it's just engineers think very differently is the problem.
mm.
It's not a bad thing. Like everyone has a different skill set, and you need all these skill sets to make successful technology. Um, I use all these tools in the very early phase of a project, right? So you're not worried
Mm,
so much about performance requirements. That comes much later. So all these
mm.
tools are just in the early phase, scoping, planning. And so I haven't, when I'm in a position of enough authority, I don't have any pushback. It's very
Yeah.
hard to convince. It's very hard for me to convince senior engineers to take on these kinds of creative design centric ways of doing
Mm,
work. But when I've carved out a space for myself and I can do it very successfully, people seem to really like it. I've done a few over the
mm.
years now, and even the engineers really enjoy it. Um, so does that answer your question? I'm not sure.
Um, yeah, I think it does. I mean, I guess the answer is that it's just ways of thinking. And I mean, I've been
Yes.
looking at a lot of this idea of conceptual frames and how it sort of informs the way that you would even
Mm,
look at,
mm.
if you sell hammers, or if all you have is a hammer, then all problems are nails. And
Yeah,
so
yeah.
if you enter with that sort of conceptual frame, then you are going to look at those problems in those ways. And I guess, yeah, part of the research and that I've been doing is how do you um, make these processes accountable? How do you argue for them, and how do you move away? And I think
Mm.
something you said was really interesting, because part of the argument I'm trying to make is it is for that discovery phase. There's a
Yes.
discovery
Yeah.
phase and there's
Well,
a
yeah.
justification phase, and they're different. The tools and the ways you need to think about those things are different
Very
at those
different.
different
Yes.
stages. Yeah.
Um, in terms of, I haven't found a successful way to impose this on people senior to me. I don't know if it's
Yeah.
possible, right?
No.
But I've found once I've gotten people in the room and I lure them with chocolate,
Mhm.
right? I always bring
Yes.
chocolate to these workshops. But
Yeah.
once we've done it, people really, I've noticed people really enjoy it. That professor
Mm.
I did the workshop with, who came from Hong Kong, he said, "Oh, we should be doing this stuff more in medicine."
Yes.
And then
Yeah.
in Leeds, I did another one with a bunch of physicists and engineers for a little mini project, which I didn't talk about. But even afterwards, one of the postdocs was like, "Oh, why don't our bosses ever do this sort of stuff?" Right? After
Mm.
going through that whole process, people actually really see the value. So I don't know, I can't really help you get your foot in the door, but once you're there
No.
and people experience it and you make it enjoyable and you give them chocolate, then people come around to it and they're much more open to it.
That's it's really interesting you say that, because I this is at a theoretical. I mean, I've done these sort of co-design workshops with Stryker and Cook Medical as part of the research, and having done those processes, people get on board. And
Mm,
there's
mm,
actually Sanders and Staples, who are really big sort of authors in this prototyping and design space, talk about how you kind of need to engage in the process to believe in it. You
yep,
can't
yep.
really understand it add a description, because it is about these actions and doing. And I think this
Hmm.
maybe speaks to some of the papers and the work that you've presented here as well, that it
Yep.
is in the hands-on that you kind of understand how it works
Yes.
and functions. It's not a necessarily something you can argue for formally. It is a more informal, experiential, something
Yep.
discovered in use.
Yep.
Yeah, so thank you so much. It's really good to hear that you're doing this sort of work, and it is people see it as valuable is really nice to hear.
Yep. Yep. Thanks. Yeah, good luck.
Thanks.
Hopefully I can change a few minds. Yeah.
Yeah, yeah. Well, thank you for doing all the work
Yeah,
to
no
so I can
problem.
hopefully step in later.
Yeah. Any other questions?
I've got the obvious question about how
Yep.
large language models and AI are going to change project management.
Hmm. You know, um, I'm a bit of a heretic when everyone's running towards AI. I've been going back in the past and studying more classical mechanics and even working on these projects. There's all these project tools and ideas, and I found the simpler stuff works better.
Yeah.
The simpler the tools are, the better it is for project management. Um, yeah, so I'm not an AI guy, and I can't really say how large language models and everything are going to change project management, but I think it works best when it's simple. And when I was in Leeds, they used to have weekly meetings and people would chat. And one guy was like, "Oh, we really need AI to write up the meeting minutes." And I thought, well, instead of having a chat, maybe we've had a planned discussion, writing an agenda, it would kind of fill itself out, right? So there's this idea that we just throw technology and it will solve a problem. It's like maybe if we're just a bit more disciplined and thought a bit more carefully, these things will sort themselves out. Does that answer it?
Yeah, I think so. Yeah. Yeah, it's going to be interesting.
Yep.
Any other questions?
Yeah, I think. Well, I just to follow up. I think we're embodied. Actually, in that book, he talks about embodied cognition, and we're embodied creatures. So
Mm.
I think being in a room, sitting with people, working with post-it notes and writing stuff on a whiteboard, really engages you in a way that sitting behind a computer can't.
Mm.
Yeah. So yeah, I'm not sure. I'm not sure about the future of AI and project management, but I think there's something to be said about doing everything hands-on. Definitely.
Yeah, I agree. Muge.
I have a personal question. What drove you away from art, or are you still making art? Um,
Uh Oh man, I try and start up the hobby again every now and then. So I actually studied, for context, I did art for 5 years in high school
mm,
and I loved it. It was my favorite subject. But when I went to university to do digital media, I just didn't enjoy it at all. Um, I wasn't ready to study. So I did an apprenticeship in a factory and then I was surrounded by robots and I decided to study robotics and I was really good at it. But I realized what I'm good at is spatial thinking. So art and engineering, to me, I think spatially, geometrically about these problems. So to me, they're not separate. They're kind of very related. And when I look at equations, I can almost see pictures of them, right? So when I'm solving a math problem, I can sometimes think about it as a picture. Um, so I'm way too busy. I really should get back into doing my little hobby art stuff. I did a drawing course during my PhD, which was really fun. Um, Yeah, I should make more time for it, definitely. I think it's good to diversify your mind laterally, and they can help with solving robot problems.
I mean, you sound more like a like an architect in a way, because I have architecture background,
Right?
so we do think
Okay.
spatially, and we do need actually researchers who are interested in uh, like on-site construction and robotics,
mm.
um, because it's
Can I jump in for a minute?
yes, please.
I mean, you say I sound like an architect. I guarantee if you speak to some of my colleagues, they tell you I do way too much math. So
Well, I
I do get very deep into my mathematics. I do enjoy doing
yeah,
applied math, but yeah,
I mean, we do a lot of maths in architecture,
yeah,
especially with the computational tools, and
yeah.
um, not that people are aware, but yeah, I do think that there is definitely need for roboticists to be more interested and involved in the construction sector, and
Mm.
because we realize that it is a people problem in the construction side.
Yes.
Um,
Yep.
and also, it's a very dynamic environment where you really need to think spatially about how
Mm.
robots are, I guess, utilized in that space. So I don't know, what are your thoughts about this? Maybe how do you see the future of construction in relation to robotics? Um,
I know So at UTS in the Robotics Institute, we did quite a bit of infrastructure robotics, right? And I actually have a friend, former colleague, who's doing his own startup for construction robotics. So it seems to be taking off. Yeah, I think it's a place where obviously there's a lot of value to be added in terms of safety and efficiency, but again, it's very human-centered environment. So yeah, I think having this kind of human-centered approach to design and problem solving will be very valuable. But even just as a researcher, it always brings up really interesting research questions. So even if researchers don't want to have to do design and work with people, even just doing that in the early phases of research can lead to really interesting questions. But yeah, I agree. Yeah, it's something that is a good skill set to have. And like I said, being an engineer, I know the temptation to avoid people, but I think all technology requires people at the end of the day. So it's something we should engage with seriously. Yeah.
Thank you.
Anyone else?
I have a question for you.
Yes.
So following from John's question, not so much about project management, but maybe how has AI influenced how you do research? Is it something that you use? Is it something that you also avoid for research?
Well, yeah, that's a biased question because you know me very well. But I use it for program. Actually, I do use it for research quite a bit. I use it if I need code that I don't really care about and I just need an output, then I'll get AI to program it. My most popular GitHub repository was writing a ROS2 wrapper for MuJoCo, the robotics physics simulation. And people really like it, but it's something I don't care about, and I just ChatGPT, write this code for me. So in that sense, it's been really useful for developing code. I do actually use it when working on tough research problems. It's really good to bounce ideas off, and I'll kind of debate and argue with it, and that refines my own understanding of really complicated maths and physics problems. So that's been very valuable because it has the whole internet that it can search. So if I'm just talking to one person, they have limited knowledge, but the AI can search all of human knowledge. So that's really helped me with my own self-learning. Where I think it fails is I've discovered it can't do anything new. So when you're really working on something cutting edge, AI just can't cut it. It can only tell you what other people have already done. So yeah, like I said, yeah, it's very useful. I use it all the time. It's a great learning tool, but at a certain point, you just have to sit down and do the hard work. And I don't think that will ever go away. In terms of actual research, like I said, I mentioned I've gone backwards in time to do more classical mechanics and really understand it from first principles. I think that's really important. I don't know if is my audio still working? I think my headphones have cut out.
We can still hear you, but maybe you
Oh,
can't
one of
hear
them.
us.
Okay, one of them. No, one of them's cut out. Okay, it's all right. It was beeping and it was running out of battery, but I can still hear through the other one. Okay. Yeah, there's all this research in. No one's really doing control anymore, and they think, oh well, we'll just throw AI and deep learning to solve every problem, but it doesn't really lead to new insights. So I'm not sure how this will evolve in 10 years, but I think there's a lot of value still in not using AI to solve complicated problems and instead trying to think them through very critically.